Hello, thank you everybody. Thank you. As you might have seen, there's some gift bags on your table, and I just wanted to give you a quick reminder. First of all, welcome to our workshop. I wanted to go ahead and give you a quick reminder that it is a wireless charging mouse pad, but there is a cable in the same box, so make sure you don't discard that cable. Go ahead and open it all the way. There's a little box in there, and that's what's going to allow you to charge that mouse pad so you can stick your phone on there and charge it. Great. Awesome. Thanks, everybody.
All right. Hello, everyone. So just before we start, I'd like to make a little survey. So here, who is a data scientist? All right. Who's a software developer? Okay. Who's a manager? All right. And who's just curious? Can be probably everyone. Okay, so that's great. Okay, so I'm Patrick. And this is Zara, and we have John down there, and basically today we'll be showing you how to build an AI product using our tool, and maybe I'm jumping ahead, but it's we're officially releasing our new tool today, and I'll be presenting it to you, and this is what we use to build that AI product in 1 hour, but think of it as a cooking show, and I'll explain the process behind this. So I think you all know about the incredible advances in AI. That's some of you. It's probably why you're here. You're like, okay, I need to know what's going to happen, and I made this little graph to make sure that we all know like what's happening. So basically, from a text prompt, you'll be able to create pretty much everything you want, whether it's an image, a document, a video, a voice, and you'll see some of them will be presenting in the AI pipeline that we'll be building today. And also from a text prompt, you can write some code, and even some of that code is 100% functional. It works super well, and it's really well written. And all the other way around works. So if you have from an image, you can get a caption. That means a description of what's in the image. From a video, you can basically have a description of what happened in the video, and so on. So all these are connected, and in between each of those bubble, basically, there's an AI model that is doing that. And every day, there's a new AI model, so much better than the one from yesterday, and I'm saying like today and yesterday, and it happens every day. There are really groundbreaking results in AI all the time. So, and as you know, now things like the LLMs, like GPT-4, Claude 2, and so on, and Llama 3, they're all able to perform better than humans better than 99% of humans, 93% of humans in most standardized tests. So this is kind of, okay, that's a lot is happening here. There's also AI automation. So this means there are little software, pretty crude, quickly made, that are able to generate really, really functional code automatically, search the web, extract information, gather data, save it, use it again, and so on, and to build software for this. All this in an automatic manner when you connect it to, say, a large language model, whatever is locally or on the cloud API. So from there, we're seeing that the advancements are exponential. So every day there's a new thing, and the thing from yesterday is getting old. And so this causes problem like us. Basically, we help companies integrate AI inside their companies, big industries, and we found that it was really hard to keep up with the new advances. And we realized, okay, so we have all these clients. We're trying to get them the state of the art. We want the best solution for our clients. And then we realized that it's really hard to keep up. And then when we basically take one of this code You start using it. Oh, I'm able to generate images. I'm able to classify images. I'm able to do such and such with this state-of-the-art model. It was really hard to share it between the team. Where we had trouble, like, okay, so it takes a long time to run on your computer. When you succeed, all right, I've got some result. Then after this, you want to transfer it to someone. It takes a day or two to work on two different machines. So all this got us thinking, okay, we need something that allows us to do this. And it's not quite an easy thing. And we looked everywhere. What could we use to solve this problem? But we could not quite find what we needed. And also, when you want to connect two pieces of code, state of the art, great results together, it's really hard to connect them because there's a conflict in packages and so on, and it's always hard to make two software, very different software, work together and exchange information. And in my life, I'm kind of managing a lot of AI projects, and also I'm coding, I'm developing, and so on. And it took a lot of work to manage the team and figure out who's going to do what and how to bring everything together. So based on all that experience, we thought like there needs to be a new tool to achieve this more faster, better, and for it to be replicable. So the vision became more like, what if we could just drag and drop GitHub repos? I take this state of the art, I know it works, so I take it, I drag and I drop it in my solution, and then to continue that vision, what if I could connect it like Lego blocks? So I take this amazing repo, take this one, two nice pieces of code that I know they give great results, I connect them together, and now they can exchange information. Okay, so that's great. And then we thought like, okay, so that would allow us to really accelerate. But then there's these stories about low code where you need to use pre-made blocks and so on. But that for us that was not enough. What we needed is to be able to go deep in the code, change everything, erase everything, bring my code in. So we need full access to the code all the time because we're developers and we don't want to be told exactly what to do. We want tools that helps us get there, but we don't want to be told, okay, you have to write all this yourself, or we wrote it all for you. You want to have control over the code. So the idea behind this is like, okay, so what if we could operationalize GitHub repos and also keep up with those advances? Because, last week there was a new model that came in, and I mean, every week there's something like groundbreaking. And you're like, okay, I need to try it. I need to see if it fits in my solution. And if I have an already running AI pipeline, and I realize that this new code is so much better, I want to swap it easily. So that's basically trying to continue a bit on this dream. And the last part, which is for us, we're working on it, and it's coming soon, is what if I could deploy this big pipeline that I created with one click, and I can access GPUs, because this computer is nice, but it's not, it doesn't run the speed I need. So today, we're officially launching ZetaForge. It's on GitHub. It's open source. So you can start using it. You can start just telling us what you think. There's also a Discord channel. So if you want to join, we're really happy to hear all your comments, good and bad, and so on. The goal is to make that vision that I showed, where we took really large steps towards this, but we want to push that even further and make this tool a perfect tool for the community. And so ZetaForge, the way it works, so I talked about those blocks, and what we're doing here is basically we're connecting them together. So what we do around each piece of code, we create a very light interface that says, okay, these are the inputs, these are the outputs. All this needs to run in a container, a Docker container. It needs to be isolated from the rest. And that's whatever you do in the code there, no one cares. As long as you have those two inputs and outputs, it can happen. So many things can happen inside as long as you control that flow. The code can run it at its own container, transfer the information to the next, so you can do really, really large computations on Kubernetes clusters, and that means that you can have access to a lot of resource. So in this case, this is just an example. So you have the input on the left. It passes to aircraft detection. You have some visualization related to the model. There's some analysis, more visualization, and then you can send to one of your server, one of your database. So this is just a very simple example. We'll be looking at one that is a little bit more advanced. So what is a block? So like I said, it's a code plus a very light interface. It's a JSON, basically just saying what are the inputs, what are the outputs, and that's pretty much it. Where it runs in a container. All these containers are kind of connected together. There's a little engine that makes sure that all the data passes correctly between the containers, and you can build so many things. You can put a full GitHub repo, almost drag and drop. You can wrap the light interface around it so that you can use it, and you can put it in API, and we'll see. What we'll be presenting, we have something that connects to OpenAI's API, to also Stable Diffusion, and so on. So basically, we have all that access, and if you want, you can connect using your code in whatever language you need. You can connect to a database, extract data, process it, send it back. It's up to you what you want to put in there. And here it can run any, because it's in the Docker container, it can run any language as long as you follow that small interface. And that's the idea behind this. And we built this so that it can really, you can accelerate and dispatch all these section of code, dispatch them to different team members, and so that it's easier to deal with and manage. So, and one nice thing is that the second you have a nice block, then you can share it, you zip it, you send it, and then that's it. It should run the same way for every developer. And that was the key behind this, is that when you do it once, you don't have to do it ever again for any other people. Everyone can do it the same way. So that's the idea. And like I said, this is it's not low code, it's full code. So that means when you click on that little button there, this means that you're opening your code or the code that was used to create this block. So you always have access to the code. You can change things there, save again, run the block differently. You can do that. So one of the example here, so we would assemble, so here on the, it's written file, you can choose a file, and in this case we drop the block, and I'll be showing the demo later on. So basically you drop your file, you select your file, and this is a very simple example. You would put some parameters, you connect it to the main block, and I can add a lot of different visualizations. So you can visualize stacks of videos, images, text, and so on. So every time you have computation happening in a block, you connect a visualization or even any type of HTML page that you want. So that gives you full power on how you want to customize your visualization. The nice thing is that we're starting to create a lot of these blocks, and since it's open source, a lot of these blocks will be coming up, and people will be able to use it, drag and drop it, so you don't have to do those nice visualization if you don't want to. But if you want to create your own, you can also. It's HTML basically. So that's the idea. In this case, CannyEdge just extracted some of the outline. So. And like I said, you can bring your own code. The goal is a kind of, I like to dig really deep in the code, but I'm also very lazy. So I like to use packages. I like to do pip install, the package come. I use the function, I'm super happy. I really doesn't matter how they did it, but I know the answers has been tested by the community. I like that. But also I like to assemble things my way. So this software is meant to do both. Basically, we built it for us so that we can kind of go fast on dropping those blocks, because if I did one for a Stable Diffusion that generates images, and that's the latest, I don't want to have to do it many times. If a team member did it, I don't want to have to redo it. So the idea is just drag and drop it, and I can customize inside. So that's really made for devs, and we'll also explain to everyone, like I said, with the visualization. If you need to explain, create some visualization, then you can add a special block that allows you to do this. So some of the blocks will be available with the software, and we'll be pushing a lot as it goes. So if you want to follow us on social medias, LinkedIn, and so on, then you'll see we'll start posting a lot of our blocks, and when the community produce really interesting blocks, we'll also push them around so that everyone can start building their own and actually using other people's very powerful block / packages / very well contained code. So So yeah, so the tech, like I said, is really about running it on Kubernetes clusters, so it can be local. Kubernetes runs locally. It runs in our clouds, and it can run on your own cloud. So that's how we decided to do this. Is that we thought that we don't want to create one cloud solution and then force companies to go there. We want companies to be able to deploy on their own infrastructure because data should not leave a company. I'm sorry, but we learned that, we know that. So data should stay within a company. So the idea is, I mean, it seems like it could be a lot of work, but in this case, it's one little server, a Kubernetes cluster, and then you're set. Your data should stay there, and you can follow all your good practices for how you manage the data. So that was the idea. So that's when we designed this. It needed to run first on the computer and then on a local computer, because if a data scientist wants to start using it, they don't want to be sending it to Zetane Cloud. You want to start using it on your computer with the data that you already have access. And later on, if you say, okay, that works really well. Now I'm going to ask if I can put it on our local cluster, and then you can go from there. So in our case, we'll be also offering people who want to do compute, so that you can stop waiting and waiting and waiting, so you can have access to good machines. So yeah, so what we build, the product that that you will actually kind of be building today, is moral stories for kids. The idea is you want your kid to learn about a new something that you just realize your kid needs to learn something, and you don't know how to explain. You say like, please clean the cat litter every day. so that example is from my son. So I want my son to clean the cat litter every day. So the idea is you send that as a prompt. I would like a story about Pokemons, and I want the kid to learn to clean the cat litter every day, and then it generates a story for them. So it's a very tailored story. So that was the product that we built. We assembled that in about a week. The way we did it was by dispatching each of these sections to the members of the team. And we had nothing to start with, so really we started from scratch. But now all these blocks are made, so now we can reuse them in so many ways without any issues. So those are examples. I want to teach my 6-year-old girl to eat more carrots, use a princess and a dragon for a story. That's all you need. And you need maybe an API key to a large language model. And I guess I can show maybe some of the example. So this is an example of what was produced. And I don't think we'll have that. Yeah, we don't have the sound connected, but basically it also generated the text-to-speech. So this means that not only we generated an image, or we generated the text per page, generated the image, and also did text-to-speech related to this, to generate this audio here. And it generated all the pages. And, oops, oh, I think it was playing. Yeah, so those are, and then we have all these images. Wow, internet is very slow. But yeah, so that created a small story that did the job. So a few of the kids around got like specialized stories lately while we're building this. So. All right. Yeah. Yeah. Okay. So that's and this is the way we built it. Is that we assigned? So we did the outline of what the pipeline should look like, and that's a key thing that I think you'll be learning today. Is how to think as in Lego blocks, how to think in Minecraft. How do you think of the small pieces that you need to use in there? So we realized that these were the main section of code, the main blocks. One is text-to-speech. The other one was to tell the story based on the prompt. The other one was to publish on the website, because what you saw was a website that was generated and then pushed on the GitHub server and then created into a page. And then you needed to generate those images. So these are the main parts. And the way we did it is that, okay, we don't have time, so, okay, meet Zara, go to Stable Diffusion, Storyteller, Zara took it. I took how to publish on a website and create the website, and then we did also text-to-speech. So, and all this, we didn't really talk too much. We just, everyone did their part, and after that, we assembled it in a big pipeline. So we really kind of, it parallelized the work. Usually this would be a nightmare, like something like that, and the time that we did is probably impossible. It would be some kind of Python, it will be some kind of notebook, and people will be sharing code. Then you'll start running it. Oh, it doesn't work. I don't understand. Oh, but that dependency conflict with this one, and then sometime we'd be spending. In the past, we spent months. I'm not joking. Just to get two of those things together that works correctly is really challenging. This, it runs on your computer. It will run on the other person's computer, and then you connect it because there's an interface between the code. So this worked really well, and we managed to create it. So now the activity is as follows. So you came to a workshop. So basically you'll be working a little bit. So these are the blocks that we use to create that story. And your activity, your job as the Lego students of the day would be to take Post-its. You see there's all the boards on the side. So you would take a Post-it. You can write the name of those models, those blocks, and the goal is to recreate the pipeline yourself based on what is written here. So each word here, so I think there's one there, text to image, so that was the Stable Diffusion one that generates images. So you can write it, and now you can create a line in between each of them, a little bit like we had here. So basically you need to connect it. So. And I guess I'll be giving like about like 15 minutes. So you can work per table, and then we'll be reviewing who's the best. And I'm sure I don't know, are there prizes for that, or we'll figure something out. So yeah, so per table you can go grab a board. You see the pen there. You can write on the black, so you can use the pen to connect the Post-it. Post-its are the blocks, the pen are the links between it. If you want to add some input, output, you can, but just let's keep it really at the eye level if you want. So, all right, clock is ticking. Go tables. Okay, so now is the time for the solution. So which team think that you have the solution? Them? Was it verified? I think this one was verified. Good. You have the solution also? Okay, let's go see. Let's go. Yeah, yeah. What's the name of your team? We didn't come for. We didn't come with the name of a team. Okay, so that's the name. All right. All right. So text input, GPT storyteller, API key. Story to image. Almost. There's one thing that's missing, I think. Yeah. One thing. Maybe it's there, or I didn't see it. All right. Oh. Two, but it's yeah. But that's good. Yeah. That's a. I'd say that's a win.
Okay.
This one is a.
It's a win. Wait.
No, I didn't say it's a win-win. It's okay. Everyone will win. This is like there's maybe one thing I don't know if maybe I didn't see it, but it's the ethics. Yeah. All right. So. All right. Let's see. All right. Okay, so now is the time for the solution. So I think you guys did a really good job. I've seen some really good pipelines, and that's good. Okay, so let's see. So here's the pipeline, and I'll be doing in the software right away, but I'll just go really quickly over it. So you see here you have the text input. You have the two API keys. So I know I only gave you one, but that's fine. So don't worry about the stability AI key because you can have both. You can call the API if you want, or you can use a local block with the model already there. So that's up to you. These I didn't give because they're just the visualization. So basically they're the text. So the first one here is the storyteller. After this, it's the ethic reviewer. My fingers don't work. Okay, yeah. All right. Okay. So here you have the API keys. So this one goes to the GPT storyteller. So and we have also the text, which is basically what you want the book to say to your kid, and you can also tailor to the name of the child. And also you can add a few things. And also I made it rhyme if you want. You can say, okay, make it rhyme. So it will create the story with some rhyme. That was the idea of my son. He said, oh, I wanted to rhyme. Okay, so I listened to my client. So after this is the GPT reviewer. And this we'll talk about it a little bit more in detail. But the reason is that things like OpenAI, they have their own reviewer inside. But if you're using Llama 3, which is on your computer, you can get some very special stuff if you're not careful. So it's good to have a reviewer that is trying to put what is being produced in context. So this one is connecting to OpenAI's API, but you could also use a Llama 3 or whatever other model, very old ones if you want, in the block itself, so it never leaves your infrastructure. And you would put really, it's important to put a reviewer or two if you want. So then, normally we would think, right away I can pass the story page by page because it generates, the storyteller creates one page, or it creates a JSON object with the words for each page. So you cannot just pass it directly to Stable Diffusion. You kind of need to manipulate to kind of, I'd say, clean up the prompt so it works really well for creating an image that's related. So Zara worked a lot on this, and basically she needed to say, okay, so re-describe the character and so on. So we have some continuity between the images. And of course, there's a lot of work to be done there to improve that all product. But as a case for today, it works perfectly, and the images follow. It's usually the same kid with the same hair color and so on. So that's already really good. And here we see, like, I guess I'll show some of the text. So this is some of the text that's been generated, and it passes through. In this case, the reviewer was pretty okay with whatever was written, so it didn't change anything. The prompts were created. And just so we're really clear of what's happening here, when I said it's full code, it means that the code is all here. So if you want to modify it and rerun it again, you can. So what you have here is the prompt to kind of help the LLM to make those decisions. And you can add how many functions, how many repos that you need. And you have certain files. And this is the Docker file, very simple file. Sometimes if you're just running Python, it's always the same. And you have the requirements, in this case, wow, OpenAI. But that really is all you need. And this will work for everyone, and that's really the idea. So that's when I say full code, it's there. It means it's accessible in one click. You know what it is, you know what it did. And as you go on, it creates the Stable Diffusion. Here we have a visualization, and that's a way to review it. So that's the carrot kid, needs to eat carrots. So these are all the image per page that were generated. And all right. And in this case, I have the result aggregator, which brought everything together. So it's really just taking the file paths, making sure it's all there. And this is the audio. I don't know if I click, it's going to... No, we can't hear it, but it's basically that's the voice of, in this case, the person kind of narrating the book. And then we send it to a React book. So basically, this is a website builder. I did some bunch of React, and I'm just passing the data. I dropped it in public, compiled a website, and now I created a website just using this block. So this means that you cannot just do it for kids' storybook. You can do it for PowerPoints, whatever website you want to create. You create all your AI data, comes in, gets dropped into a React, which is kind of state-of-the-art. All these things are state-of-the-art, and that's kind of the key part here, and maybe I didn't insist enough, is that all these models, it's all the best of the best. I mean, maybe since yesterday, I don't know. So maybe today it really changed, but the idea is that we can use all these state-of-the-art things, connect them together, and get something that is what it is, and something that is state-of-the-art. So the sum of state-of-the-art is usually state-of-the-art, if you kind of put the glue correctly. And so in this case, we have a website. And in this case, I decided instead of sending it to our servers to publish the website, or Netlify or Heroku and so on, I decided I don't want to mess up with their API, so I sent it to my GitHub repo, my personal repo. So basically the website with all the data is now in a repo. Every time I run it, I kind of have a new repo that appears as my personal thing. I don't know how GitHub feels about it, but that seems to be legal. So I have like all those repos with those random names. It's kind of nice because then I can see what was produced every time. And then I made a call that says, take this, because it's a website, publish it on GitHub pages. And then basically I created a website using good old GitHub, and it works really good. This works really well. I have now, I don't know, 50 websites since we started that, and it's all a storybook. And then I plugged in the QR code maker, and if you want to take just a picture, then you'll get the website from there. And yeah. Yeah, as the single thing. All right. Yeah, and then you...
Once upon a time, in a colorful village, there lived a young boy named Timmy. Timmy had curly red hair and wore glasses.
Yeah, so basically now you have also the narration, you have the images and so on, and so you can basically tailor a book to a kid. And yeah, so I guess now I'll let Zara Continue.
Thank you, Patrick. Okay. So yeah, as almost all of you went through the pipeline, there's one of the blocks there that's the GPT ethics reviewer. I want to just briefly discuss it with you. So the GPT ethics reviewer wants to make sure that the story generated by GPT is actually in the correct context and also suitable for your child to listen to. So the way I made this block is that simply I put a prompt and I use this prompt, attach the input story to the end of the prompt, and ask the GPT to revise the story if it's necessary. So the prompt is, you're a story editor responsible for carefully inspecting a given story to check if it is ethical and suitable for children. Make any necessary modifications to ensure that the story is appropriate for children. And this way we can ensure that our pipeline is safe and responsible. This is an example of how it can modify anything if necessary. So for example, in the prompt, it says, teach a child to be careful of bloodthirsty, violent monsters, and you don't want that for your children. So the GPT reviewer does the job for you and instead changes it to teach a child to be cautious and aware of their surroundings. It also works well if the story, if it was generated by another model, if the story needs modification, it would also modify the story accordingly. So there's also, as Patrick mentioned, you can use GitHub repos and just wrap GitHub repos in a block. So there's an easy way to do that. You can just, you should just put a few blocks in there, a few files in there. So you would need a block interface, which is just a specs file that specifies the input and output variable names. But the good news is that you don't need to do that manually. I'll go back to that later. But you would also need a requirement.txt file, which lists Python packages and the versions that you need for each GitHub repo that you want to use. There's a Docker file. You may not need to modify it, but if you want to add a step to your Docker file, you can do it. And then there's the computations.py file, which includes the main logic of your block. And so in the image here, you can see there's the compute function that includes the main logic of your code. And then there are a bunch of inputs and some outputs. So if you want to change, modify the structure of your block, the only thing that you would do is that to change the name of the inputs here and the outputs, and then you would compile your block, and it would update the structure of your block for you. So it's very easy to work with. And you can also add a folder containing the GitHub repo or any other files that you need to add, like a model checkpoint or whatever you need, a config file. You can just add it in the same directory that your block exists, and then that's how easy it is to wrap a GitHub repo. You can visit the code on GitHub. You can support us by starting our GitHub repo. And also feel free to make contributions, open a new issue. Yeah, support us on GitHub. And thank you. You can come and see us at our booth.
All right. Well, thank you. That's it. All right.